Chapter number 1, Natural Numbers. Now the numbers 1, 2, 3, 4, 5 all the way to infinity are called natural or counting numbers. We categorize natural numbers into 3, although a number may feature in 2 categories depending on the defining features of that category. Even numbers are all natural numbers that are divisible by 2. So the first 5 even numbers are 2, 4, 6, 8, and 10. Odd numbers are the exact opposite of even numbers. They are not completely divisible by 2. There is always a remainder of 1. And so 3, 5, 7, 9, and 11 are odd numbers. Do you think 1 is an odd number? Now the third category are prime numbers, and prime numbers are numbers that are only divisible by 1 and the number itself. 2, 3, 5, 7, 11, and 13 are the first 6 prime numbers. Notice that all prime numbers except 2 are also odd numbers. 1 is not a prime number and 0 is not a number. Adding a given number a number of times. For example, 21 times 3 means 21 plus 21 plus 21, and we get 63 as the answer. For small numbers, that might look simple, but when dealing with large numbers, it will get more complicated and tedious. So then we multiply the numbers. In multiplication, each digit must be multiplied by each digit in the multiplier. So for the case 21 times 3, we shall have 21 here and 3 down here. Then we put the multiplication sign in front of 3. 1 times 3 is 3, and then 2 times 3 is 6. So our answer is 63. What of 21 times 35? We arrange it like this and we put the multiplication sign here. You can either start multiplying by 5 or by 3, but the key thing is your answer must always be written starting below the multiplier you chose. In this case, 1 times 5 is 5, so we write 5 below here. Then 2 times 5, we have 10. Then we multiply by 3. 1 times 3 is 3, and we write it down aligned with 3 here. Then 2 times 3 is 6. Then we add these 2 and we have our answer. We could also have started multiplying by 3. 21 times 35, so we have 1 times 3 is equal to 3. We write it here. Then 2 times 3 is 6 here. 1 times 5 is 5, we write it here. And lastly, 2 times 5 is 10 there. We add and the same answer. Notice that 21 times 35 is the same as 35 times 21. When we multiply a number by a multiple of 10, that is 10, 100, 1,000, 10,000 and so on, we simply add the equivalent of zeros to the number. If you multiply by 100, you simply add 2 zeros. So 59 times 1,000, we just add 3 zeros to the right of 59 and we shall have 59,000. Division. In dividing whole numbers, the knowledge of multiplication is important. And whereas 81 times 3 is the same as 3 times 81, 81 divided by 3 is not the same as 3 divided by 81. In the operation 81 divided by 3, 81 is the dividend, 3 is the divisor, and the answer you get is called a quotient. So quotient times divisor is equal to dividend. You remember the long division method. 81 inside and 3 outside. 3 goes into 8 2 times, so you write 2 at the top. Then 2 times 3 is 6. You write 6 below 8. Now subtract 8 minus 6 to get 2. Drop 1 to make this 21. 3 goes into 21 7 times, so our quotient is 27. We try 3,480 divided by 15. 3,480 inside, 15 outside. 15 cannot go into 3, so we go to 34. 15 into 34 2 times. 2 times 15 is 30. Subtract from 34, we have 4. Drop 8 to have 48. 15 into 48 3 times. 3 times 15 is 45. Subtract from 48 and we have 3. Drop 0 to have 30. 15 into 30 2 times. So our quotient is 232. Sometimes in this operation, the divisor may not divide into the dividend completely. The remainder is written alongside the quotient. For example, 263 divided by 5. 5 cannot divide into 2, so we go to 26. 5 into 26 5 times because of 25. Subtract, you get 13. 5 into 13 2 times because of 10. You subtract, you get 3. Nothing to drop, and 3 is the remainder. So our answer is 52 and a remainder of 3. When the divisor is a multiple of 10, you simply cancel the equivalent of zeros on the dividend starting from the right end of the number. For instance, 145,000 divided by 100, we cancel 2 zeros and have 1,450. However, not any zero can be cancelled, only the zeros to the far right end. For instance, it will be inappropriate if you had this and then you cancel like this. It is not right. Only the last 2 zeros can be cancelled. Finally, rounding off numbers. Let's go back to the population figure of Kenya. 14,876,293. Now, if such a figure is provided, it simply suggests that the person who did the survey was so accurate, so much so that he counted the people to the last man standing, which in practical sense is not possible. What we normally do is give an estimated value which could be higher or lower than the actual figure. We call that rounding off. When we do that, we reduce the accuracy. We can round off numbers to any place value depending on the degree of accuracy we need. To round off a number, we go to the place value we want. Check the digit that is next to it on the right. If it is 5 or more, add 1 to the place value digit and replace all the other digits to the right with zeros. If on the other hand it is less than 5, we retain our place value digit and replace all the digits to the right with zeros. For instance, in our figure, let's round it off to the nearest 10,000. The digit at the 10,000 value is 7. Next to it on the right is 6. So we add 1 to 7 and replace all these digits with zeros, and we get 14,880,000. To the nearest 1,000 now, place value at the thousands is 6. Next to the right is 2. 2 is less than 5. So we retain 6 and replace all these others with zeros. So we have 14,876,000. Try to round off the number to the nearest tens and hundreds.
I love that math generally has initially clear and precise answers, that you know when you know it and you know when you don't know it. As you get farther on in it, the answers are not so clearly in the back of the book, but initially math has answers, clear answers. Sometimes they're hard to find, but that clarity. The second thing I love about math is it's a puzzle-solving kind of if I can figure it out, and the joy of figuring it out, the kind of sense of accomplishment, the sense of excitement when you get it, the challenge of trying to get it, it's that puzzle solving kind of thing that I really, really like.